Hi, and welcome to our screencast on the Binomial Theorem. My name is Carrie Chen, and I'm here with my group mates Dimitri Akimaru, Alan Kong, and Isaac Olson, and together we are Group B12. This screencast and many others on various topics in discrete math can be found at www.noatom.com, which will be linked in the description box below. And it's a great resource if you're looking for introductory level topics on this sort of stuff. Okay, so let's get started. Let's go over a bit of background on binomials first. So a binomial is just the sum of two terms, like x plus y. And the binomial theorem gives a power of a binomial expression as a sum of terms involving binomial coefficients, which involve combinations. So most people are familiar with simple cases that involve the binomial theorem. For example, if we have x plus y squared, we can expand this to x plus y times x plus y. And if we do a bit of basic math, we get x squared plus 2xy plus y squared. Likewise, if we have x plus y cubed, we can do x plus y times x plus y times x plus y. And again, if we multiply it all out, we can get x cubed plus 3x squared y plus 3xy squared plus y cubed. Oh, let's just get rid of that. Okay. However, instead of multiplying it all out and then adding all the terms together, which can kind of be a lot of work if we go into higher powers, we can look at the same expansion and apply the binomial theorem reasoning to get the coefficients. So if we go back to the last example of x plus y cubed, and we're trying to see what the coefficient of the term x cubed is, we see to get x cubed we have to pick an x from each of these three sums. And that occurs in choose three ways, which equals 1. So the coefficient for x cubed is just 1. And likewise for x squared y, we need to choose two x's out of these three sums. So we get 3 choose 2, which equals 3. That gives us our coefficient of 3 for 3x squared y. And if we do the same thing here, we want 1x, so we get 3 choose 1, which is 3, giving us 3x y squared. And for y cubed, we want 0 x's out of these three sums up here. So we have 3 choose 0, which equals 1, giving us 1 y cubed. And if you compare this to multiplying it all the way out, we get the same coefficients. So if we generalize this type of logic, we can get the binomial theorem. Oh no. Alright, technical difficulties. Where the slide will not advance. Love it. Okay, there we go. So here we have the formal statement of the binomial theorem, which is this right here. And this seemingly simple idea can be used to prove many apparently random inequalities that we will touch upon later. But first, let's do a proof of the theorem. If I can get the slide to advance. Okay, so we're going to do a combinatorial proof here. And so the terms in the product of x plus y to the n, when you expand it out, are all of the form x to the n minus j times y to the j, where j equals 0 to n. So to count each of the terms, we have to realize that it's choosing like the number of y's. There are j of them. So you're choosing j from n possible locations. So then the other n minus j terms are in the product x. So therefore we have n choose j of these terms, x to the n minus j times y to the j, which gives us our theorem if we sum it over j equals 0 to n. So, and this is a generalization of the kind of reasoning we used earlier in our x plus y cubed example. Alright, so let's do a proof that uses the binomial theorem. So we have to show that 2 to the n is equivalent to the sum from j equals 0 to j equals n of n choose j. So if we see here that 2 to the n equals 1 plus 1 to the n, we can see that this is just a case of binomial expansion where x equals 1 and y equals 1. So we can apply the binomial theorem here to get this, where 1 to the j and 1 to the n minus j, which is just equal to the sum of n choose j, which is what we were looking to show. Pretty simple and straightforward. Okay, so on to a couple of example problems. First, we have to find the coefficient of the 13th term of x plus y to the 30th. So generally speaking, the kth term of the expansion has the form a times k to the n minus k minus 1 times y to the k minus 1, where this term a is the coefficient that we want to find in this problem. So if we set k equal to 13 in this case, and n equals 30, we can just find the coefficient by applying the binomial theorem. So we have n choose k minus 1, which is equal to 30 choose 12, which gives us a coefficient of 86,493,225. Okay. Oh no. Okay. Moving on to our second example problem, we are asked to find the value of the sum from 0 to n of n choose j times 5 to the j. So this problem's a little more tricky, and if we look carefully, we can see that this is a special case of the binomial theorem, and we should probably work backwards, because this sum is equal to this, 5 to the j times 1 to the n minus j, because anything times 1 is itself, and 1 to the power of anything is just 1. So in this form, we can see that this is just a binomial theorem with x equals 5 and y equals 1, so we can work backwards and plug this into our general statement, giving us 1 plus 5 to the n, which gives us our answer of 6 to the n. Okay, well that finishes up our screencast on the binomial theorem. If you want to see more videos on this topic or on a number of other related discrete math topics such as sets, proofs, and inductions and other great fun stuff, please visit noatom.com. Thanks for watching.